All right, so let's look at another example. So example. We're still on the factor theorem. Now, so they're saying use the factor theorem to factorize x to the power 3 minus 6x squared plus 11x minus 6. Okay, so we need to find to use the factor theorem to factorize that. Now remember, we have to find factors on our own, okay, the ones we feel like can fit into this. So we can either choose numbers, okay, just choose numbers that should be the value of x. Okay, so let's say, okay, let possible factors. So the best way is to consider the constant. Okay, so possible factors of 6. Okay, so we'll say there is 1. Okay, when you do 6 times 1, you have 1 as a factor. Okay, you have 2, you have 3 times 2 gives you 6. You also have 6. Okay, but you also have the negative side of this very same factors can also be factors. Okay, so negative 6, all those can be factors of these polynomials. All right, so what we're going to start doing is we're going to try them, all of them, using the remainder theorem, and whatever gives us 0, okay, that will be a factor of that polynomial. Okay, very important. Okay, very important. All right, now so let's start with x equals 1. Okay, if x is equal to 1, that means we can move the x, the 1 that side. It will be x minus 1 equals 0. That means our divisor is actually, our factor is x minus 1. Okay, remember this. Okay, that's our factor, our divisor. But so what we have to experiment on is substituting f of 1 into our polynomial. So it will be 1 to the power 3 minus 6 to the power 2, 6x to the power 2, plus 11x minus, what am I doing? My goodness. Okay, sorry about this. Okay, let's start properly. Okay, so the first factor, possible factor of 6 that we're going to use is x is equal to 1, and then we'll substitute. Let's write our polynomial first of all. X to the power 3 minus 6x squared plus 11x minus 6. So let's substitute 1 into that. Okay, let's substitute 1 into that. Okay, so it will be equal to 1 to the power 3 minus 6. We substitute 1 there, squared, plus 11, we put 1 there. Okay, and then minus 6. This gives us 1 minus 6 plus 11 minus 6. This is negative 5 plus 5. This gives us 0. Therefore, x equals 1 will give us a factor, because if we substitute 1 into that, it will give us 0 as a remainder. So we move the 1 this side. Okay, move the 1 that is with x minus 1 equals 0. Therefore, the factor is g of x equals x minus 1. Okay, this is our first factor. From there, let's use let's try out f of 2. Okay, that will be 2 to the power 3 in the polynomial minus 6, 2 to the power 2 plus 11 times 2 minus 6. That gives us 8 minus 4 times 2 times 6 is 24 plus 22 minus 6. Okay, that gives us negative. That gives us negative 16, and this one gives us, my goodness, what's going on? Okay, this one gives us 22 minus 6 is actually plus 16. That gives us 0. Therefore, x is equal to 2 can bring us a factor. We move the 2 that side with x minus 2, giving us 0. Therefore, g of x equals x minus 2. This is another factor. Okay, here's another factor. And then from there we need to look at the other values as well. Okay, we need to look at the other values. Now remember, you may ask the question to say, where do we stop substituting? Okay, because we can just go on and on. Actually, we won't go on and on and on and on. This thing is actually a cubic function, meaning it's x to the power 3. That means the only values of x that would actually work in this case are 3 values. 3 factors will be what we'll choose. So here we're on factor number 2. It means we're remaining with 1 because this is a cubic function. Okay, so let's find the final factor. Let's find the final factor. Okay, so let's find the final factor. So we'll use x equals 3. Okay, so f of 3 gives us 6 and gives us 3 to the power 3 minus 6 3 to the power 2 plus 11 times 3 minus 6. Okay, that gives us 3 to the power 2 is 9 times 3 is 27, and then there is 9 times 6. 9 times 6 is actually 54. Okay, yeah, so it's 54 minus 54 and then plus 33 gives us minus 6. Okay, now from there we'll get 27 minus 54 plus 33 minus 6, giving us 0. So x equals 3 can also give us a factor. We move the 3 that side, is x minus 3 equals 0. Therefore, g of x equals x minus 3. Okay, so those are the factors of this one. So how do we show our factorization? We'll show it this way. Okay, let me remove this. Okay, I hope you're able to follow this. Okay, so it means x to the power 3 minus 6x squared plus 11x minus 6 is equal to, okay, so x minus 1 multiplied by x minus 2 multiplied by x minus 3. If you expand this, it should give you that. That's how we've factorized it. Okay, we've simply found factors by looking at factors of the constant. Okay, we've found factors that can be possible, substituted them into the polynomial. After finding the ones that are giving us 0, we would come up with a divisor, maybe the actual factor of the polynomial. Okay, those ones, if you put them together and expand them, they should give you the original polynomial. That's how you factorize using the factor theorem polynomials that may be complicated in any way. You can do this. Okay, that's how we do it. Alright, so that's where we'll stop for today. Catch you in the next video.